Good evening, students. I welcome you all for this session. So today we are going to start with design problems. That is, first we will take a design of singly reinforced beam. So in the last class we have seen what are the different steps to be followed in the design of singly reinforced beam. So let us take one problem, okay, and we are going to design singly reinforced beam. So the problem is like this: design a singly reinforced beam of clear span 5 meter to support a working live load of 15 kN per meter. This is a live load. Then adopt M15 grade concrete and Fe415 grade steel. Okay, and after the design, you have to sketch the reinforcement details. And for this, you have to assume bearing is equal to 380 mm. Bearing is nothing but the support. Whatever you are seeing, this support is nothing but a bearing. Okay, so with this data, let us draw a sketch. Okay, this is the longitudinal section of the beam. So this is simply supported beam as it is given a singly reinforced. Okay, and it is a simply supported beam. Okay, so from inner edge of the support to the inner edge of the support is a clear span, and from center of this support to the center of support is effective span, small l. Okay. And in the previous class we have discussed the first step is you have to find out the depth of the beam. That is, first you will calculate effective depth of the beam, then overall depth of the beam. So let us first consider effective span, that is small l. Now see here, effective span is equal to center of this bearing to the center of this support. Okay, that is called as effective span l. So effective span l is equal to center to center distance between the bearing. So clear span, okay, this is the clear span plus half of this bearing plus half of this bearing is nothing but one bearing we are going to add, or one width of support we are going to add. So clear span is 5 meter and half of bearing is given as 0.38. Okay, that is all. So half of 0.38 plus half of 0.38. So we are going to add one full bearing. So the effective span of the beam, okay, from center of the support to the center of support is 5.38 meter. Okay. Now the actual steps we are going to start. What is the first step? We have to find out the depth of the beam. Okay, effective depth of the beam. So for that, what are we going to assume? So let us assume L by D ratio. We call it as L by D ratio. That is small l by small d. Effective span divided by effective depth. So since it is a simply supported beam, so the L by D ratio will be, we can assume maximum 20. Okay, and depending upon the span also, depending upon the effective span, let us consider L by D ratio is equal to 12. Okay, so since this load is 15 kilonewton meter, we can assume 12 to 15. So let us assume L by D ratio is equal to 12. Okay, next, once if you assume this, now see, L is known, okay, this ratio is known, we can find out the effective depth. So therefore, effective depth D is equal to L by 12. Okay, that is effective span divided by 12. So what is the effective span? 5.38 meter it is. Okay, now let's substitute in millimeter, that is 5380 divided by 12. So this effective span, effective depth small d is equal to 448.3 mm. So it is a fraction. You are going to convert this, or you are going to take into rounded value higher side. That is 450 we are going to consider as small d. Okay, so effective depth of the beam is equal to 450 mm. So what? So from this, once if you get the effective depth d, right, add 50 mm to this. So add 50 mm, right? So overall depth is equal to what? It is a clear cover plus half the bar diameter. Okay. So let us assume clear cover is equal to 25 mm. So for beam, right? So remember clear cover for the reinforcement. Okay. So the reinforcement is not directly placed on this bottom of the beam. So at a clear cover, the bars will be placed like this. Okay. So this distance is called as clear cover. Okay, so for beam you can assume clear cover is equal to 20 or 25 mm. Okay, and even you can assume the diameter of main bar. So whatever the main steel is going to provide for the beam, you can assume 20 mm. It is not like that you have to assume 20 mm only, right? So what you have seen in the points you have to remember, right? So at any condition the diameter of the main steel should not be less than 12 mm. Okay, for the beam, main steel diameter should not be less than 12 mm. So you can assume 12 mm, 16 mm, 18 mm, 20, 22 like that. So let us assume the diameter of main bar is 20 mm. So therefore effective cover, okay, effective cover means from bottom of the beam to the center of reinforcement. So clear cover is 25 plus half the bar diameter. So 25 plus half of this is 10. So the total effective cover is equal to 35 mm. So now once again we are going to calculate effective depth. So effective depth D is equal to capital D, that is overall depth, this overall depth, okay, minus effective cover. Okay, so overall depth capital D minus effective cover. So capital D we have taken 500 mm minus effective cover is 35. So finally we arrive the effective depth of the beam is equal to small d is equal to 465 mm. So let us conclude that overall depth of the beam, that is capital D 500 mm and effective depth small d 465 mm. Okay, so this is the first step. We have to find out D and this effective depth. Now let us consider the second step. What is the second step? So the second step will be B, width of the beam. Okay, so let us take width of the beam as 1/3 of effective depth to the 2/3 of effective depth. That is 1/3 of D to the 2/3 of D. So 1/3 of 465 to the 2/3 of this 465. So any value between 155 to 310 mm will be considered as width of the beam, that is B. So let us again you can make round to, let us provide width of the beam B is equal to 250 mm. Okay, so finally this is the dimensions of the beam. So that is width of beam is equal to 250 mm, effective depth is equal to 465 mm and overall depth is equal to 500 mm. Okay, so this is the important step. Once you find out the dimensions, next go for the third step, that is effective span of the beam. Okay, initially we have calculated it. Okay, so one more criteria we have to consider. So what is effective span? Effective span is least of the following. There will be two criteria. Out of these two, whichever is the lesser value, that will be the effective span. Now see here, the first criteria is center to center of bearing. Okay, center of support to the center of support. One criteria, that is clear span 5 plus 0.38. Half of bearing one side, half of bearing one side. So effective span is equal to 5.38 meter. Then second criteria, clear span plus effective depth. Okay, clear span, that is capital L plus small d. So clear span is 5 meter and effective depth, whatever you have calculated, 465 mm. So substitute in meter, it is 0.465. So effective span is equal to 5.465. So these are the two values. So out of these two, whichever is the least value, that will be considered as effective span for the beam. So now lesser value is this 5.38. So finally effective span of the beam is equal to 5.38 meter. Okay, so this is the third step. Okay, then fourth step is important, load calculation. So whatever the load which comes on the beam, okay, so the beam has to take the bending moment. So that bending moment is what? Due to the loads. Then what are the loads? The loads from the slab, okay, will come to the beam. So it is in the form of UDL. Okay, that is first dead load, or self weight of the beam, own weight of the beam we are going to calculate. So what do you mean by self weight? Self weight is nothing but its own weight. So how will you calculate self weight of the beam? It is area, gross area. See, I am saying gross area means it is B width into capital D. Now see, if it is a beam, okay, this is width of the beam and this is overall depth of the beam. This is capital D. Okay, so B into D will give gross area. So area multiplied by density of RCC. So in this beam, concrete is also there, then bars are also there. Okay, so the density of RCC you have to take. So if you are taking density of RCC, it is 25 kilonewton per meter cube. Okay, RCC means density 25 kilonewton per meter cube. If you are taking only plain concrete without reinforcement, only concrete, then density will be 24. Remember. So here RCC is there. So B is 0.25 because this is in kilonewton meter cube. So that's what B and D are substituted in meter. So 0.25, that is 250 mm means 0.25 meter, 0.5 meter into 25 kilonewton per meter cube. So the total dead load of the beam will be 3.125 kilonewton per meter. Means what it indicates? Okay, at every 1 meter, for 1 meter beam, how much will be the load? 3.125 kilonewton. So for 1 meter length, 3.125 kilonewton will be the dead load. Okay, this is first self weight of the beam or dead load of the beam. Second is live load. So live load, it is given in the problem. So live load is given in the problem as 15 kilonewton per meter. As the name indicates, live, right? The load which are moving. Okay. So suppose if you are sitting in a one room, above your room one more floor is there. Okay. So there the people are moving from one place to another place, or some materials are moving that. So those loads are called as live load. This is self weight, dead load. Okay, it is dead load. This is moving load or live load. So it is given in the problem 15 kilonewton per meter. So these are the two loads. Add these two loads. So total load small w. I am writing small w because it is in the form of UDL. Okay, this total load, all these loads are in the form of UDL. So therefore it is 18.125 kilonewton per meter. So it is working load. I am not writing WU. It is W. So working load is 18.125 kilonewton per meter. Therefore factored load, okay, that is WU now. Okay, if you know the W, multiply 1.5 factor, so you will get WU. So WU is equal to 1.8 into this load into 1.5. So this comes out, okay, as total factored load WU is equal to 27.50 kilonewton per meter. So this is the total load. It is in the form of UDL. Now see here, I have shown here over the beam entire span. So this total load W is 27.50 kilonewton per meter. Now the next step is calculation of maximum bending moment. Now see, this is a simply supported beam with UDL throughout the span. Okay, so there will be maximum bending moment at the center. Okay, so what is the maximum bending moment? Now see, for simply supported beam, right? For simply supported beam carrying UDL throughout the span, the maximum bending moment will be calculated as WL square by 8. Okay, if it is a simply supported beam, it is WL square by 8. If it is a cantilever beam, it is WL square by 2. Okay, so now in this case it is a simply supported beam with UDL. So ultimate moment or maximum bending moment MU is equal to WL square by 8. So W is this WU 27.5 L effective span it is, okay, 5.38 square divided by 8. So the total bending moment or ultimate moment or factored moment MU is equal to 99.5 kilonewton meter or 99.5 multiplied 10 to the power of 6. This will be converted into kilonewton to Newton, then meter to millimeter. So this is the maximum bending moment, right? will be at the center of this beam. Means this beam will going to bend like this. Okay, this beam will, because of this UDL, this will going to bend like this. The maximum moment will be this. Okay, so to take this maximum bending moment, what you have to require? The beam should not bend like this, right? So how are you going to accommodate this? Okay, so we are going to provide the reinforcement at the bottom. Okay, so since the tension comes at the bottom, okay, so this will be the tension zone, and top this is the compression zone. So tension comes at this bottom, we are going to provide the bars, okay, at the bottom. So after this, the next step will be what? We are going to calculate the how much reinforcement is required at the bottom of the beam. Okay, so this is the one part of this problem. So the next part, that is calculation of reinforcement, then calculation of shear reinforcement, then check for the deflection, and we are going to draw the sketch. Okay, so that video I am going to share tomorrow. Okay, so I hope you understood this. Okay, once again go through this problem. First step is finding out the dimension. Second step is width of the beam. Third step is effective span of the beam. Fourth step is load calculation. Fifth step is calculation of maximum bending moment. Okay, then the next step is calculation of main steel. Okay, then calculation of shear reinforcement, then calculation, that is drawing of, check for the deflection, and the last longitudinal section we are going to draw, and cross section we are going to draw, that we are going to show the reinforcement provided in the beam. So let us conclude this problem here only. So tomorrow I will continue from this where I am going to left today. Okay, the next part of this will be we are going to see in the tomorrow's video. So thank you very much for attending this class. If you have any doubt, okay, so at any time you can contact me. I am going to clarify your doubts. So once again I thank you all for this session. Thank you.